Does anybody else need one before we get started? I know.
You're a horrible student.
Come on, Dan.
It wasn't my fault. You just called me a horrible teacher, but Hayden didn't hand back the paper.
Hayden, you're a horrible person.
No, you're not, Hayden. You're beautiful inside and out. All right. So today we are going to prove those two theorems so you can start using them in proofs because I know that's exactly what you want to do. Tomorrow we are not doing any notes. I will hand you a worksheet with a bunch of proofs on it, and you guys will do those proofs during class. I will walk around and help you. If you have not done your construction portfolio yet or turned it into me, you will be working on that during the hour tomorrow. Do you understand me? Who else hasn't? I just know one person. That's why I stared. Sorry. And Lindsay, right? Okay, good. And I can help you through that too, just so you guys can get stuff turned in so that is not a 0 in the grade book. All right, so let's start with this. Proof that the base angles of an isosceles triangle are congruent. So the first thing we need to know is that we're going to construct a perpendicular bisector at some point in this proof, and I will show you exactly that with my compass. You do not need to pull out a compass and do it. You can just draw the line in when it comes to that point. Do you guys understand that? Okay, so what is given to us? Tell me what's given to me. Yes?
Angle A is congruent to angle B.
That is not what's given to you. That is the then part, so that is what you're trying to prove. So we're trying to prove angle A is congruent to angle B. So what do we know? What are we trying to prove? So that's the conclusion we're trying to prove. Yeah, the hypothesis is?
ACB is isosceles.
Okay, so let's get started there. So the first thing I'm going to do is make a 2-column. I'll do a flow chart on the next one. That way those of you that are in different places and like different things can see both ways. So the first thing I know is triangle ACB is congruent to, or not congruent, is isosceles. What do we know because it's isosceles? Who remembers what you know when a triangle is isosceles? What do I know if something is isosceles? Carmichael? So we know that AC and CB are congruent because that's the definition of an isosceles triangle. So we know that AC is congruent to CB, and that's the definition of an isosceles triangle. Where? This?
No, on the very top, when you first start writing, ACB is...
This here?
Yeah.
That is a C.
Oh.
It just doesn't look like a C because sometimes it's really hard to write with the stylus, so I look like I'm writing like I'm a first grader. So. No, you're fine.
I blame you. Miss Brady, I was at Walmart and I saw like the package of stylus that you bought, like that one and the pencil, and the people I worked, they're like, who would buy these? I was
And you're like
Miss
my math
Brady.
teacher would. Duh. All right. So if we're going to construct a perpendicular bisector, so just pay attention. You should know how to do this because on your last construction portfolio, you guys had to construct 1,000,000 perpendicular bisectors. I feel like almost every other one had that.
What did she just grab?
Those
Rubber
were like
band.
pretzels at first, and
I was like, did she just have like a bag of like cinnamon toast
I'm
crunch?
losing my voice.
Oh, that sounds so good right now.
Does it?
My voice sounds like yours as well.
Don't worry, guys. I got to get the marker first.
Do you need the iPad video?
Is this being recorded right now?
Yeah, it is. Don't worry. I don't really care, though. All right. So when you construct a perpendicular bisector through a point off the line, you swing an arc so that it hits both. We all know how good I am at this. We swing an arc so it hits both.
Nice.
This thing does not like me.
I think I could draw it better than that.
Okay, so you don't have to draw this part. So you construct that, and then from there, you are going to swing an arc above and below based on that point there to construct the bisector. Actually, I don't need to do above because the C is my above point. I just moved again.
I wish like the recording
could see how great I am at this. Okay, so if this is going to work right, I don't even know if it's going to work right because it's split so much, but you can construct a perpendicular bisector through point C. So I dropped a perpendicular bisector. So go ahead and just drop a line from C. You don't have to draw all the arcs and stuff. I'm just constructing it to show you guys something. So I constructed a perpendicular bisector. What do we know because we constructed the perpendicular bisector? Well, let me draw mine in.
Are we going to construct it?
No, not at all. I'm doing this to show you something.
You left the caps on both you.
This is why you don't have any
The
markers.
slide already put a line there.
What?
The slide already has a line there.
I put it in. You don't have a line. You had to draw it in.
No,
I just drew that in with my
no, under it.
What do you mean?
She's saying.
I know, I just drew that in, like after I did the construction. Are you talking about this line that's underneath here?
Yeah.
Yeah, I just drew that in on the iPad. All right, so before we go anywhere, we're going to say CD is a perpendicular bisector of AB, and that is construction of a perpendicular bisector because we constructed it. I mean, there's supposed to be a space there. So why is it a perpendicular bisector? So bisector means that it cuts it into two congruent pieces. So if I were to measure this, this is about 6 inches and this is about 6 inches as well. So you'll notice that a construction of a perpendicular bisector, if this is a theorem that we're not going to prove, but there's a theorem that says that if you drop a line to the midpoint from the vertex to the midpoint in an isosceles triangle, that it will create a perpendicular bisector. Meaning, if it's perpendicular, these angles are right, and these two segments are congruent. Okay, so there is an actual theorem out there that says that. So tell me some things that I know now, because that's a perpendicular bisector. Tell me some things that I know, and I'm going to label that point. Tell me something I know. What do I know? Tell me something you know because it's a perpendicular bisector. Anything? Yes?
Point B is the midpoint.
Which means that what two pieces are congruent? So that is the definition of a bisector right there. So we have AD congruent to DB by the definition of a perpendicular bisector. Do we know anything else? Do you know anything else because of that definition, or because of it being a perpendicular bisector? Kylie?
Okay, I'm guessing. So, wouldn't like the line CD be also like we couldn't you use like an flex it?
Yeah, so we can do that here. There's another way you could prove this. I'm going to do it this way because that's what Kylie said. But we know CD is congruent to CD. And that is what kind of property there, Kylie? Yeah. Do we know triangles are congruent now? Yeah, and we're trying to get that angle A and B are congruent. So are those corresponding parts of our congruent triangles? Are A and B corresponding parts of our two congruent triangles in here? Do you guys see the triangles? You see two triangles in there? Or do you think those are corresponding parts? Are they between the 1 and the 2? So do you think we'll be able to say, since those are congruent, we can use CPC-TC from there? Okay, so Gabe, tell me my two triangles that are congruent. CAB, you said? And CBD? Good. And what is the reason, Gabe?
Side.
Yep, it's side, side, side. And then finally we can say angle A and angle B are congruent. They line up. They're corresponding parts of congruent triangles, so therefore they are congruent. Yes, I just wrote a number 7 up there. Rob. There is another way to prove this. You could have used HL. If you know that it's a perpendicular bisector, just pay attention to this. If you know it's a perpendicular bisector, you know that angle CDA and CDB are right angles, right? Because it's perpendicular. And what do you know about all right angles?
They're equal to 90.
They're equal to 90, which makes them congruent, right? So then you would say, okay, so you'd say CDA and CDB are right angles. Then you would say CDA is congruent to CDB because all right angles are congruent. And then you would have had a right angle here and a right angle there. So then you could have used HL because you have a right triangle and the hypotenuse and the leg are here. Hypotenuse and leg. So you could have used HL and then proved it from there. I personally think side, side, side is easier, and I would have done that, but we haven't really done HL yet, so I just wanted to talk you through that a little bit. All right. So let's look at the next one.
I don't want to. Too much writing.
So if AC is a perpendicular bisector of BD, then AB is congruent to AD. Iku, what's my given information? Greg, what am I trying to prove?
AB equals AD.
AB is congruent to AD. Okay. So let's get started there. Oh, actually, I'm going to do... So, what do I know because AC is a perpendicular bisector of BD? Tell me something I know. What is something I know because that is a bisector of that? Bisect means to cut into two equal parts. Perpendicular means forms right angles. So, what do I know? Hayden? BC is congruent to CD by the definition of a perpendicular bisector. So that's one thing we know. We know something else because of that perpendicular. What do we know because of that being a perpendicular bisector? What else do we know because it's perpendicular? We're saying that AC is perpendicular to BD. What do I know? What kind of angles are formed when it's perpendicular? So what are my two right angles?
ACB
Good.
and ACD.
So we know that ACB and ACD are right angles. So that comes off of here. I'm going to put it that way. So angle ACB is congruent to angle ACD by the definition of a perpendicular bisector. Not congruent, so sorry. That was bad on my part. Are right angles. So those are right angles. And that's the definition of a perpendicular bisector. And what do you know about all right angles? All right angles are 90 degrees, which makes them, if they're both 90 degrees, then they are, what are they? If they're both 90 degrees, what word can we say? Congruent. So angle ACD is congruent to angle ACB because all right angles are congruent. Okay, so I have two pieces of information so far. Do I know anything else? Greg.
The reflexive property.
So what do we say there then?
AC equals AC.
AC is congruent to AC by the reflexive property. Do we have enough information to prove triangles are congruent? Austin, what two triangles are congruent? ACB and ACD. So triangle ACB and triangle ACD. And why do you say that, Austin? Because of side angle side. Okay, but that's not what we're trying to prove. We are trying to prove AB is congruent to AD. Are AB and AD corresponding parts of two congruent triangles? So therefore they are congruent themselves. So AB congruent to AD by CPCTC. Sorry, that says CPCTC in the black down there. Let me... There you go. Okay, questions there. So we're going to just run through what you guys just learned, and then I'm going to get you guys your homework out for the last 10 minutes. And then again, I'm not teaching you anything new tomorrow. Just come in ready to work. Come in ready to work. Come in ready to work.
This is the 2 days. That's stupid.
We're here. So some theorems and corollaries. So Isosceles triangle theorem. If two sides of a triangle are congruent, then their base angles are congruent. So if sides then angles, or if angles then sides, works both ways. So if you have two sides congruent, you can use the base angles theorem in your proofs using the Isosceles triangle theorem, which says if two sides are congruent, then their base angles are congruent, now that we've proved it. Corollary, a triangle is equilateral if it is equal angular, meaning if all the angles are the same, then all the sides are the same. All the sides are the same, then all the angles are the same. So if you know that, you can say that. Each angle of an equilateral triangle is 60 degrees. All right.